That's Trogdor. If you don't know who Trogdor is, sorry. Packet. Beverage. Okay, we're on page 2 of the packet, and we're going to do some decimal expansion work. And for this, you can just grab a calculator if you want, or you can just have me do it for you right here. Let's look at 1/7. This builds upon what we looked at the other day with terminating decimals that repeat 0, and then you divide by 3 and you get single digit repetition. Okay, so what happens when you take 1 divided by 7? Well, you end up with something like that. What do we have here? 142,857, 142,857. Oh, 0.142857. And what you have here is a repeating block or group of numbers. So the the repeating bar has to go over all 6 of those digits. If you look at this, it does repeat 142,857, that block of 6 over and over and over again. And anything that repeats in terms of decimal expansion is rational. Okay, so right here where it says, does every fraction have a decimal expansion? Well, we'll take a look at that. But one thing that the decimal can do is it can terminate or repeat 0. Now, I'd like you to write both those things. Terminate, comma, repeating 0. And then we have a rational decimal expansion, which came from a fraction. Number 2, you can have a repeating single digit, like we saw the other day. So when you divide by 3, when you divide by 9, you get single digit repetition. And number 3, now we have this next, it's still repetition, but it's like, wow, now you're repeating an entire group or block of numbers. So we have a repeating group. And that's also a rational idea because you understand it. It makes sense. It's measured. I can tell you what the next digit is going to be based on the previous selection of digits. Okay. All right. What happens when you go 2 divided by 7? Okay. 285714, 285714. Whoa, get out of here. Check this out. 142857. That's what we just wrote down right there. But I see it when you take 2 divided by 7, but now we start in a different spot of that group. It's 285714, and it's that 6 digits, but it's the same 6 digits repeating over and over again. We just start in a different place in that group, okay? And the same thing's going to keep happening. You take 3 divided by 7, it happens again, only now this time we start with the 4. So if you look back here, 42857, and that's exactly what we have right here. 42857, 42857. Well, this is wild. This is cool. This is really cool. Okay, maybe you don't think so, but I think so. I like it. I like when stuff makes sense and I understand it. 1 1/7, we're just going to tack on. Oh, don't forget your repeating block of numbers. 1 4 2 8 5 7 with a 1 as the whole number. Okay, here's something that fascinates me. This is not going to be in your notes, but I just want to do like a simple exploration of this. We divided by 7, and the 7th digit was the one that repeated. Check this out. 1 2 3 4 5 6, and then on the 7th digit it repeats. Okay, so is that true of other things when you divide? Does the denominator tell you when it's going to start to repeat? So let's do 1 divided by, I don't know, 17. That's a lot of numbers. That's what they said. We actually did this in class in one of the Zooms. Like, that's a lot of numbers, bro. Like, yeah, it is a lot of numbers. What did I divide by? 17. I got it right here. Okay. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And on the 17th digit, we now have repetition. We have 0, 5, 8, 8, 2, 3, 5, 2, 9. Whoa. That's wild. And my question is why? Like, why does this happen? Why? I don't know. I honestly don't know. I just think it's really cool. And I'm not the greatest mathematician in the world. I'm a middle school math teacher who just thinks things are neat. And maybe if I spent some more time and researched this, I could figure it out. Maybe I could. Let's do another one. 1 divided by 19. Okay. So if we hold true to form, it'd be on the 19th digit that it repeats. And I think we have it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 19. Whoa. Okay. Strange. Weird. But I like it because it makes sense. And I understand it, so it must be rational. Yeah, that's what I'm getting at. If you understand it, if it's plausible to get the next number, you can follow that sequence. It must be rational. So what do I notice? Lots of numbers, bro. Now I notice that we have a repeating block, repeating group. And anytime that happens, notice how I started. 1 divided by 17, 1 divided by 19. These are fractions that I'm starting with and dividing numerator by denominator to get a decimal expansion. And by looking at that and noticing that it repeats, you have this key word of repeats. Even if you repeat 0, that's still repetition. Repeating single digit, obviously, 0.3 repeating, 0.4 repeating. Repeating group, 142857, 142857. The common thread between those is you have something that repeats, that you can duplicate and know what's going to happen. So therefore it's rational. End of lesson. So the next time we dive into this, we'll talk about this crazy world of numbers called irrational. No, it's hard in class when I say it. Rational, irrational, and sometimes you don't hear the IR in front because I don't speak that well, but I try. And let's get back to it. So finish this video, which is now, and get your work done.